Hey guys, welcome to another awesome video, and today we are continuing with our June exam and we are doing functions. If you still haven't subscribed, make sure that you hit the subscription button so that you are notified whenever I post a video. So without any waste of time, let's just go straight to the questions. And over here we are given question 4, which has f of x is equal to x squared minus 2x minus 3, and we have another function which is g of x is equal to x minus 5. So we are asked 4 questions or 5 questions over there. The first question is pertaining to the turning point of f, which we know that the function f is a parabola, and we need to determine the x and the y intercepts of f, and then also we need to determine the turning points of both functions, or the point of intersection of both functions in 4.1.3, and then in 4.1.4 we need to sketch the functions on the same system of axes. And then the last question, now we need to determine the values of x, where now f of x is greater or equal to 0. Let's just go straight to the questions. For the first question, it's pertaining to the turning point, and we know that we can use the equation of the axis of symmetry to find the turning point. Now for the equation of axis of symmetry for a parabola, is x is equal to minus b over 2a. So now we know that a quadratic function or a parabola is y is equal to a x squared plus bx plus c. So now what we need to do is use a and also use b. Now the value of a over here is going to be 1. If you look over here, it's 1, and then the value of b is negative 2. So meaning that for us to find the axis of symmetry, we need to say negative, and then it's negative 2 over 2 times 1, and that is equal to 1. Now we have found the first coordinate of the turning point. Now in the next coordinate we need to substitute into the function, so we need f of the point 1, so which is equal to 1 squared minus 2 times 1 is 3, and which gives us negative 4. Therefore the turning point of this function is equal to 1 and negative 4. So that's how we find the turning point. But also what we can do, because we've learned another skill in grade 12 which comes from calculus, what we can do is differentiate and equate to 0, and then we can find both values of the turning point. So without wasting time, let's just go to the next question. And of course over here we have the question that needs us to find the x and the y intercept of f. So now remember, in the x-intercept, we have our y equal to 0. Now if we're dealing with f, now this point f of x is y, so meaning that now everything which is x squared minus 2x minus 3 should be equal to 0. And of course we need to factorize over here, and that is x minus 3 and x plus 1 is equal to 0. Then now we know our x values is equal to 3, or x is equal to negative 1. So now we've found our x-intercepts, and if we can write them down as coordinates, we'll have 3 and 0 over here, and then we'll have negative 1 and 0 over here. Then for the y-intercept, now if you look at our function here, it's written in the form y is equal to ax squared plus bx plus c. Now the value of c is your y-intercept, so meaning that it is written in intercept form. So now what we can do, now we can take our negative 3 as c, so meaning that now our y-intercept is 0 and -3. So very simple there. So let's go to the next question. So for the next question, we need to determine the points of intersection of both functions. So now remember, at the point of intersection, so P or I, at the point of intersection, we know that f of x is equal to g of x. Now f of x is given by this equation here, and g of x is given by this equation. So meaning that we have x squared minus 2x minus 3 is equal to x minus 5. So now what we do here, we take x and -5 to the other side, so we have x squared minus 3x plus 2 is equal to 0. So very easy there. Now our next step is to factorize. So now our factors will be x minus 1 and x minus 2 is equal to 0. So now we have x is equal to 1 or x is equal to 2. Now these are our x values for our points of intersections. We need to find the y values. Now for the y values, we know that we can substitute in any of the two functions, but the easiest one to substitute into is g of x. So I'll just pick g of x. So I would want g of 1, which is equal to 1 minus 5, which is -4. Then I would want g of 2, which would be now 2 minus 5, which is -3. So now the coordinates of the points of intersection would now be 1 and -4. That's your first coordinate, and then the next coordinate here would be 2 and -3. So very simple there. And in our next question over here, now we are required to sketch the functions in the same system of axes. Now for us to sketch our parabola here, we would need our x-intercept. So let's just say for intercepts here, our x-intercepts, we found out that our x-intercepts would be first, if we refer to the previous questions over here, x-intercept is 3 and -1, and then your y-intercept is 0 and -3. So if we can just summarize them here, for f of x, we have the x-intercept, which is the first one was x is equal to -1, and then the next one was x is equal to 3, and then your y-intercept, we had that we had the point 0 and -3, and then your turning point, we had 1 and -4. So that was a summary of f of x. And then now for g of x, we need to sketch this function, and we don't have the x-intercept, but we know this is where y is equal to 0. So meaning 0 is equal to x minus 5. Then now x is equal to 5. Then for our y-intercept, we know that x is equal to 0. So meaning that now y is equal to -5. So we have two points here. We have our x-intercept, and then we have our y-intercept. So now to sketch them in the same system of axes, now to sketch my function here, I'll just have to have my, here's my y-axis, and then I have my x-axis over here, and then here's my origin. Now I need to put in my points here. So firstly we have our first x-intercept of f, which is -1, and then the second one would be 3, and then we have our y-intercept over here, which is -3, and then let me just make room for our turning point here. So for the turning point, it's just next to so it's -3 over here, and then our turning point is going to be somewhere here, which is now what, it's now 1 and -4. So now if I sketch my function, I have to join all of these points, and I start from my x-intercept, going to my y-intercept, turning there at my turning point, and there's my function. So let me just polish it up. So I have the graph of f. Then now for the graph of g, I have 2 points here. The first point is going to be my x-intercept, and then the next point is going to be my y-intercept. But now what we need to notice here is that initially we had proven that this is the turning point of the function, and then now we further agreed that the point of intersection of the two functions is also 1 and -4. So meaning that now the linear function will intersect the parabola at x is 1 and y is -4. So meaning that the function will go like this. So that's what we have over here, and now we'll have a y-intercept of -5 and an x-intercept of 5. So that's how we sketch our two functions here. But now there's another point that is missing that you need to also show, is this point of intersection. And remember, we said that the two functions will intersect at 2 points, so meaning this point is the other point of intersection, which is 2 and -3. So very simple over there, and we continue to the next question. This question over here, it says use the graph to determine the values of x where f of x is greater than 0. Now if we go to our function, f of x is greater than 0 means that we need the values of x which the function is above the x-axis. So if we look at my 2 points here, my 2 intercepts, if I go to the left of -1, the function proceeds to be above 0. If I go to the right of 3, the function proceeds to be above 0. So meaning that x is less than -1 or x is greater than 3. So very simple. So for your answer over here, we have x is less than -1 or x is greater than 3. So very simple there. Let's just go to the next question. 4.2, we are given an exponential function over here, and we have to write down the equations of the asymptote of f. Now if you look at the function here, the function seems to be converging on the x-intercept, so meaning that it is approaching the x-intercept, but does not reach the x-intercept. So the answer to 4.2.1 is that the asymptote of the function is y is equal to 0. But now we can also see it in the function, because now an exponential function is written as a b to the exponent x plus q. Now q being what? Being the horizontal asymptote. So q being the horizontal asymptote, and if we can see over here, the value of q is 0, so that's how we find the equation of the asymptote of f. The next question is write down the inverse, the equation of the inverse of f in the form y is equal to. Now you would have known that when we do inverses here, we use logarithms. So y is equal to 1 over 3 to the exponent x. Now you might have missed it, this is to the exponent x. So now what we need to do first is to swap the x value and the y value. So here's x is equal to 1 over 3 y, and for us to write this in the form y, we need to use logs. So y is equal to log 1 over 3, let's just put this in the bracket, x. So the function is log 1 over 3x. And then if we continue now, the question says sketch the graph of the inverse on your answer book. Now guys, remember, when we are sketching this function, we swap the x and the y values. Now if you look at over here, the y-intercept here is 1, which will be transformed. Let me just use a green color here for the inverse, so this would be 1. So remember, the coordinate over here in the original function, we have what? We have 0 and 1, but in the inverse now we'll have what? We'll have 1 and 0. Then now we go to our asymptotes. Now for the asymptotes, if you look at your function over here, it has an asymptote which is y is equal to 0. Now your new asymptote will be over here, so let me just do it in green, will be over here, which is now what? Which is x is equal to 0, so meaning that your function will approach here but will not reach it. And then another thing that you need, guys, just to make sure that you sketch the right function. So I always tell my learners that if you are sketching functions, just make sure that you work with the easiest method that you can work with. So if you want to draw the inverse, just make sure that you create just smaller than 2 points here, just to find out the shape, because some of you are struggling with the constraints and the shape. So what you can do is create a point here. So maybe let's say over here is going to be -3, and then over here it's going to be 3. So now this would be what? This would be -3 and 27. Then this point here would be 3 and 1 over 27. So very simple here. Then now, if you are going to sketch these 2 points on the inverse, what is going to happen here is that you'll have 2 points. This will translate to 27 and -3, and the second point will translate to 1 over 27 and 3. So very simple. Then now, how are you going to sketch? We're going to start with this one. This is negative 1 over 27, which is a bit closer to 0, or between 1 and 0, but now the value of that function is going to be a 3, so somewhere here. And then now we go to 27 and negative 3, so negative 3 is somewhere here, but 27 is somewhere here. So now if you look, that helps you find the shape, because we are going to use these 2 points here to make sure that we have the correct shape. So just fictional points that make sure that you sketch the correct function and you know the shape. So very simple, just a nice trick to make sure that you get full marks. Then we go to our next question here. We have write down the equation of the asymptote if now the inverse is shifted 2 units. Now remember, if we have plus means shifted 2 units to the left. So now if we look at our function here, our function has an asymptote x is equal to 0. If we shift it 2 units to the left, our asymptote will end up being here, which is now x is equal to negative 2. So our answer here is going to be, so 4.2.4 is going to be x is equal to negative 2. That is the new equation of the asymptote. And then now we go to our final question, which is 4.2.5. Prove that this expression is equal to this expression. Now let's just write the first one as the left hand side. The left hand side is equal to f of x squared minus f of negative x squared, right? And then the right hand side, we have f of 2x minus f of negative 2x. So now let's just explore these two sides. Over here we are given that it's f of x squared. Now if you look at f of x is equal to 1 over 3 to the exponent x. So we need to square this, hence the square bracket. So we need to square this. Now if you square f of x, we'll have that the left hand side is equal to 1 over 3 to the exponent x squared minus, then we have now a different function, which is f of negative x. Now if we're going to have f of x, and f of negative x is going to be 1 over 3, and instead of x we're going to put negative x and we square it. Then now if we simplify the left hand side, we'll multiply the exponents, so it's going to be 1 over 3, then we'll have to the exponent 2x minus 1 over 3 to the exponent negative 2x. Now if we realize 1 over 3 is the same as 3 to the exponent negative 1 to the exponent 2x minus 3 to the exponent negative 1 to the exponent negative 2x, which now simplifies to 3 to the exponent negative 2x minus 3 to the exponent 2x. When we multiply when we multiply the exponents. Now remember, a power raised to an exponent, what we are going to do with, we multiply the exponents. Then now when we look at the right hand side over here, with the right hand side, we have f of x is 1 over 3x, but instead of x we substitute 2x minus 1 over 3 to the exponent. Instead of x we substitute negative 2x. Now this is 3 to the exponent negative 1 to the exponent 2x minus 3 to the exponent negative 1 to the exponent negative 2x. So which simplifies to 3 to the exponent negative 2x minus 3 to the exponent 2x. And if you look at the two expressions over here, the left hand side is equal to the right hand side. Now let's do the mark allocations. So we started off with finding or showing that the turning point of f of x is 1 and negative 4. And now what we need to do now is we get a mark for substituting into the axis of symmetry. Yes, that is a mark over here, and you get a mark also for substituting for getting the y value, right? So if you get the y value, that is you get a mark over here for finding the turning point. But now here's a problem over here. We substituted the point 1 into the function. So what we needed to do over here, because it didn't say find the turning point, right? It said show. Now if we're going to use the axis of symmetry, we also, for the x value, we also need to use the equation. The y value of the turning point is 4ac minus 2b squared over 4a. Remember, that is the equation of the turning point in its fullest, because now the y value is minus 2a minus b over 2a, and then now the y value is found like that. So if you simply substitute into the equation, you are not showing that this is the y value, you're just finding any y value. So for you to show that this is a y value of the turning point, you need to also substitute into this equation here. But the safest option is to make the derivative equal to 0 so that you can find the turning point, and that is easier because now what you're going to do is say 2x minus 2 is equal to 0. Then now we know this is the x value of the turning point because the derivative is equal to 0. So now we know we can solve for x, and then x is equal to 1. Then now we can substitute 1 into the formula. So very simple there. Your 3 marks are, so your second mark is for substituting into the y value of the turning point. So now if we're going to find the x and the y intercept, so x intercept, very easy. Over here you get your mark for your factors, and then remember we are looking for x intercept and the y intercept. You get a mark for both x values, and then you get a mark for the y. So that is your 3 marks over here. And then we go on to determining the points of intersection. Now for points of intersection over here, what you need, the first mark that you get is for your standard form. Second mark that you get is for your vectors, both x values and then both y values, and in total that is your 4 marks. Then we go to the next one now. Let's just okay. Your next one is for sketching. So for sketching over here, what is being marked is the actual sketch. So because I have a lot of red, I'll just mark in green over here. So now, and there's thunder. So I'm actually recording while it's raining over here, so I hope you're enjoying the rain sound if you hear them over the music. So the first thing that you get a mark for here, you get a mark for the y-intercept of f. You get a mark for both x-intercepts of f, and then you get a mark for the turning point of f, and then also you get a mark for the point of intersection, and then you get a mark for the x-intercept of g, and then the y-intercept of g, and that is 1 2 3 4 5 6. That is your 6 marks. Going on to the next question over here, you get 2 marks for both answers. And then we go to the next question here. So over here you needed to find the asymptote of f. That's 1 mark. For the equation of the inverse, you have 1 mark for swapping the x and the y values, and 1 mark for the actual function in the form y is equal to. So there's your 3 marks over there. And then the next question, we needed to sketch the inverse. So for the sketch of the inverse, you get so it's how many marks? It's 3 marks. For the sketch of the inverse, you get a mark for the shape. So you get a mark for the shape, correct shape, get a mark for the x-intercept, and then you get a mark for any other point. So remember what we did, we took a fictional point, so you just put this point over here. So the point was over here, which was 27 and -3. So for one other point, so even if those points are fictional, you get a mark for any other point. So your 3 marks now is going to be coming from translating the 2 points that we had initially created to the inverse function. So that would work out well for you. And then now we go to our last question. And for our last question, we needed to prove that the left hand side is equal to the right hand side. So now you get a mark, so it's 3 marks here. So you get a mark if you're going to substitute the constraint into the left hand side, and also if you're going to get a mark for substituting the constraint into the right hand side. So now what am I speaking about? If you're going to square f of x, and also here substitute negative x, and also over here substitute 2x, and over here substitute negative 2x. So we did that over here, and for the right hand side we did that over here, and then you get a mark for simplifying for both. So that is your 3 marks, and I really do hope that you enjoyed the video, and don't forget to subscribe so that you are aware whenever I post another video. And I'll see you in the other video, in the next video, and we'll be doing calculus. So please do make sure that you subscribe. And we're trying here, it's even thundering. So I hope you enjoyed the video, and then I'll see you next time.